Okay. Audio works. I think everything is working. Okay, let's get to it then. So we're gonna start off with pre-algebra. We're gonna move on to the multiplication lesson. The previous day I already finished the addition of the arithmetic, so we're gonna just move on to 1.3 multiplication. Okay, where is my stylus? There it is. Okay, cool. So flip this over. Sorry, I'm just getting everything set up. Rotate this device. Okay, there we go. Awesome. Let's lock that. Okay. So 1.3 multiplication. Okay, so the first problem. We're already doing problems. So from 0.7. So using the two pictures below, explain why 2 times 3 equals 3 times 2. So they have this. And then they also have this. And we're supposed to explain why this here equals this. Well, just from my understanding of multiplication, multiplication is just repeated addition. So essentially all we're doing is 2 plus 2 plus 2 or 3 plus 3. So it could be either version, meaning that because this is addition, we can arrange the numbers in any order and still get the same result. So I think what they're trying to show you is that multiplication is commutative, just like addition, because multiplication is addition or repeated addition. How many times do you want to repeat this number? Well, I want to repeat 2 3 times. That's 4 plus 2, that's 6. Okay, how many times do you want to repeat 3? Well, I want to repeat it 2 times. Okay, that's 6, which means that these are the same. The equality checks out. So I'm gonna write just a simple answer. Multiplication is commutative. And for the blocks, it doesn't matter the orientation of how the blocks are set up. We can move the numbers however. So the blocks that were shown before had, it had a 3 by 2 and a 2 by 3. So they're just saying that, make sure I'm getting this right. So yeah, this is a 3 by 2, and this is a 2 by 3. So it doesn't matter the orientation or the order of the numbers, we can still move them around. So this, yeah, okay, I think I see what they're doing. Okay, so this block right here, they're saying that how many times do you want to repeat 3? I want to repeat, so I want to put 3 blocks 2 times. How many times do you want to repeat 2? Well, I want to repeat it 3 times, so place 2 blocks, or 2 blocks 3 times. And it's the same way, it's the same answer. So I cannot formulate that in words. Blocks. Same answer. The blocks represent the amount or repeated amount. Okay, I think that's a good answer. So let's move on to the next problem. 1.8. So by counting the dots in the picture below in two different ways, explain why 2 times 3 times 4 equals 2 times 3 times 4. So there's 3 terms, and we haven't moved any of the numbers. So it looks like this. And just from the prior lesson in addition, we learned about the associative property and how we can group these numbers together. So and then explain using the picture below. So it kind of looks like this. And then there's 4 dots. So my thinking is that we have these 4 dots in each circle. And we're asking how many times do you want to repeat 3? We want to repeat that 2 times. So repeat, repeat. Okay, and then we still have to add those blocks because this answer is 6. So how many times do you want to repeat 6 or 4? It doesn't matter. Well, I want to repeat it 6 times. Because there's 4, 4, 4, 4, 4, 4. So it's 1, 2, 3, 4, 5, 6. I want to repeat that 6 times. So an answer for this would be, so multiplication is associative. The terms, or I guess the group term, doesn't change in orientation, or I'm trying to think how I could say this in words. I think, okay, so we had So no matter how you repeat, or we take how many times we want to repeat the number. So we say that we want to repeat this, or the 2 3 times. So 2 2 2. But we still have the 4 squares. So I think I can say, the term is repeated by operand, but because there is number I don't really like that explanation. Let's try to think of another. I guess the term is repeated by the operand and repeated once again by the third term. Yeah, I think that's a lot better. Okay, let's move on to the next problem. Compute 25 times 25, 4 times 6 times 8. Okay, no calculator, just what they taught us. So I know that 25 times 4 is 100, but 25 times 8 is 200, times the 4 is 800, but then we have to worry about the 125. Well, I know so if we do something like this, 25 times 4 times 4 times 6 times 8. Does that make the math easier? Oh wait, it's a 5. No, it doesn't really make it easier. So I guess my best bet would be to group or move the 8 to the 25, group that. And then leave the rest of the terms alone so we can get 200. And then we can multiply the 4 and the 6 times 125. So that's 800 times 6. That is what, 48. But then the number gets hard to reason about. So let's try this again. What if we did 4? Well, that's 100. And then see, 600. So if we do that, it'd be 48. See, I'm trying to figure out, like, there's a way to make this a lot easier to multiply. Don't want to use the calculator because that's just cheating. So there is a way, like 25 times 4. Okay, 100. Do I break the 125 apart? Like, can I... I know this would be 48. It's 125. But I also know that that's just 25 times 5. Okay. Let's think about this. What if I multiply 125 times 8? I think I'll get a number. So I just gotta pull out the old little trick. Okay, so it does work out. And now we're left with, so 25 times 4, 125 times 8, 6. That's 100 times 100, or 1000 times 6. That's just 1, 0, then 0, 0, 0 times 6, which gives us this. Hold on, wait. I guess not. Okay. But how... I could have figured this out a different way. What could I have done differently? Could have said 100 times or plus 8 or 25. 800 plus 2000. And then I would have realized that's 1000. Okay. Okay, so that's my answer. Let's move on to the next problem. So using the picture below, explain why 2 times 1 equals 2. The one term is the repeater. So essentially, want to two once. Anything multiplied by 1 gives you the term back. Next problem, P1 or P11. We have to solve two problems. So 5 plus 6. Okay, so now we're mixing up addition and multiplication times 7. So this is 11 times 7, which is 77. And B is 5 plus 6 times 7. And then it's 5 plus 42, which is 47. Okay. I think why did they show us these problems? They're saying that you can't just mix addition and multiplication and expect to get the same answer, because they only use associative property, but we got different answers. We got 77 and 47. They're not the same. Okay, next problem. Using the picture below, explain why 2 times 3, 4 equals 2 times 3, 2 times 4. So the picture looks like this. We have, and these are shaded in. And they want me to use the picture. What in the world? Using the picture below, explain why 2 times. So there's a shaded part. What does this shaded part represent? Oh, okay. So they're saying that this part right here is the 2 times 3. This part right here is the 2 times 4. Because we're going to repeat the 4, or I guess the 2, 4 times. So 2, 2, 2, 2. Or the 4 2 times. So 4, 4. And this part represents the row. So the 3 plus 4 equals the row. And we want to repeat that row 2 times. It's shaded to represent the grouping. So right now they're trying to tell us that these are equal because whatever answer we get in the parentheses, we have to repeat that. hold on. So I think I have to say something like this. I have to say on the left hand expression, the group represents the row, the complete row, repeated twice. Right hand expression breaks the, or separates the blocks between the shaded part and unshaded. In the left-hand expression, the group term represents the complete row, which is 7, repeated twice. The right-hand expression separates the blocks between the shaded part and the unshaded part and tells us and when computed, becomes the same row. I think that's a good answer. That's how I kind of make sense of it. Okay, let's move on to the next one. Compute 51 times 9 plus 51 times 31. Okay, I'm just looking at the previous problem. And the theme is that, well, there's a repeated number here. So if we just do the same thing that the problem 12 did, we can get the same answer. Or we can follow the same process. So this becomes 51 times 40. That math is too hard to do in my head. So we have to, what can we do? We can break the 50 apart and distribute the 40. Okay. So this becomes 40 times 50 plus 40 times 1. Okay, I get it now. They're just trying to explain the distributive property over multiplication. So 200 plus 40, which gives us our final answer, 240. Cool. And then the next problem, 14. So we have 17 times 13 51 times 13 plus 32 times 13. Okay, so we're gonna apply that same process. There's a repeated number here, here, and here. So we're gonna focus on this part first. And then we'll get 13, 17 plus 51. And then it'll be 32 times 13. We have to represent this whole expression as just another number, because then we can easily see, like for instance, if we just ignored these numbers here and said that was A, and then we did a 32 13, or just ignore that 32 and pretended it was a B. So A equals 17 plus 51 and B equals 32. Then we'll see that 13A plus 13B, well, we can then use that same process again, that distributive property, to get the same answer. So when we see it like that, we can then say, okay, well, 13 plus or times this whole expression, combine it together, 32. We can remove that 13. We can now add the numbers that are grouped. See if I can actually do that in my head. So we have 17. So it's 49, 51, so 100. Make sure it's right. So yeah, 68. Yeah, I think that's right. So that'll be 1300. Okay, last problem. So consider the multiplication facts below. 5 times 7 is 35. 4 times 7 is 28. 3 times 7 is 21. 2 times 7 is 14. 1 times 7 is 7. And then we're saying 0 times 7 is what? Well, I noticed just from high school that it's 0. Find the pattern in the multiplication answer. So that's the problem they want us to solve. Well, when we look at the number, we see that it's just subtract 7. So the next number is just subtract 7 from 7, which gives us 0. So subtract 7, that's the pattern. Assuming that the pattern continues, predict the answer to the last multiplication. 0. I'll even be fancy, just write 0. Okay, that was the last problem. And now we have to review them. So I'm gonna pull up the red pen and see if I was right. So problem 7. Oh yeah, this one talked about the commutative property. So the picture on the left has 2 rows. Each row has 3 squares, so the total number of squares is 3 plus 3, which is 2 times 3. Okay. Yeah, they worded it way differently. my answer was the term is repeated by the operator and repeated once again by the third term. They went more descriptive on the blocks. I don't really care about the blocks. Let's see. But let's try to understand what they wrote. Let me check my OBS real quick. Testing. Okay, everything's working. I don't know why YouTube's saying that I have poor quality right now. Okay, now I have excellent. Okay, whatever. Okay, I see what they're trying to say. I guess when I was describing the problem, this is kind of what I said, but I did not write that down. I had trouble thinking how I would write this down on paper, but I get the general idea. But the picture on the right is just a rotation of the picture of the left. So yeah, I said orientation doesn't matter. From what we learned in the addition sections, that if the orientation doesn't matter, then you can conclude that, well, this operator, the multiplication operator, is commutative. Yep, in other words, multiplication is commutative as with addition. This is not a proof that community. Oh my god. That commutative property works for all numbers, but our example does give a good idea of why. So this is called the commutative property of multiplication. Let's write that down. Express through some can't write 34 because okay, so they're just explaining that we write it with a dot, or you can do it like that, or when we're doing algebra, we can do it with this when we have letters. So this new property that we've learned, a times b, is the same as b times a. Okay, problem 8. So yeah, associative property, that's what the answer they gave, and this is called associative property of multiplication. And now we have another new property that we can add. So when these are grouped, a times b times c. Well, it's the same as a times b, c. See how the numbers don't move around? They're the same, a, b, c, a, b, c. But we've just grouped them differently. So now we're moving on to the problems. So let's see if I get that one right. Yes, I did. Is that a comma there? And I did the same process, so that's good. Awesome. So I understood when I finally did like just multiplication like that 125 times 8 is 1000. But it just expected me to just know like, oh, when you multiply these numbers, it gives you 1000. Like, no, I wasn't gonna know that. Let me get some water. So yeah, we got that one right. Cool. And we followed the same process that they did. So that's good. Next problem, problem 10. And we've also learned a new property. So yeah, we got this one right, and the new property is that 1 times A is A. So any number for all A gives you back A. So that's very, very good to know. Okay, let me read this. Before we continue, we'll probably find different operators. But we know that if we just... Okay, so they're leading into problem 11, where we have addition and multiplication. I gotta read this section. So, okay, the parentheses tell us to add first. Okay, yep, we got 11, that's 77. And then B, we have to multiply. And then they go over PIMDAS. Okay, so all they're saying is that we have to be careful when, or the order of operations or these properties that they've given us don't always work when we start mixing in operators like addition and multiplication. We can't just move numbers around. We have to perform certain steps to get the correct answer. So for A, we have to add the numbers first because they're in parentheses. That's the first letter in PIMDAS. So that's parentheses. Do that. And then once we have the answer or the result from that addition, we can then multiply it by 7, which gives us 77. Okay, and then we do the same process here. 42 plus 5, we get 47, and we conclude that these expressions are not equal. Okay, I get the general concept. We just have to, so I have to acknowledge that, okay, when an expression has a like multiplication, division, addition, subtraction, I can't just do commutative property here and there and think I can move a number 7 that's being multiplied by 2 and then move it all the way to the other side, and now it's 7 minus this number. I can't do that. That's not legal. Go to jail for that one. Okay. Problem 12. Okay, yeah. I get the general concept. On one hand, they have 2 rows. Each row has 3 plus 4 squares. So altogether, there are 2 times 3 plus 4 squares. I described it differently because I see the problem in a different way. Like, there's 2 rows, and it's 7. So we know that when we get the result from the grouped terms, we get 7, and then we're going to repeat 7 2 times. So we have 2 rows of 7. On the right hand, we break apart the rows and then combine them together again. That's kind of how I see the distributive property. So this is called distributive property of multiplication over addition. Okay. So this is a rule that combines multiplication and addition. Like, this is one of the properties we can use. Okay. So the multiplication is distributed to the 2 parts of the addition. So we can now write this as A, B, C, which is A, B plus AC. Or we can write this as B plus C times A, which is the same as BA, or B times A plus C times A. Okay, so yeah, these are the same. Hold on. Got a message. Hold on. Okay, I'm back. Okay. So now we're going to see the distributive property of multiplication over addition in detail. So we're going to the next problem. So separating Beautiful. We can use the distributive property. Yep, that's what we did. And we got 40, which we then said, oh, that's too hard to multiply. So we broke 50 into 50 plus 1. And then we multiplied that by 40. So we distributed the 40. We got 200 plus 40. We got 240. Oh, wait. I did it wrong. Ah, shoot. Okay, so... Yeah, okay. Crap. Actually, I'll do this. So, this was supposed to be 2,000 plus 40, which makes the answer 2,040. Yeah, just a simple mistake, or arithmetic mistake. Man. Okay. But we get the general concept. That matters more. Like, we understand distributive property. We just don't know how to multiply. Okay, the next problem. Oh wait, they go into more detail. So this technique that I did, so that I expanded the number. And then this is its factored form. Is this expanded as well? So using... No, this would be expanded. We expanded the number. That's what they're telling me. And then when we want to go back, so something like this. So if we have a times b plus c, this is in factored form. But when we do ab plus ac, we've now expanded it. So when we... Oh Lord, I'm trying to erase this. So when we take an expression and we expand it, we get this. When we want to revert back, we have to factor it to this. Okay. And then they also talk about the common factor and how that 51 is a common factor. An example. So they don't really give any rhyme or reason why it's called a common factor. Because what I remember from high school was that these are terms, right? I don't remember them being called factors. But anyways, let's move on to the next problem. Well, let's first make sure I get this. So factored form, and then when we expand it, call that expanded form, and this is related to distributive property. Okay. Next problem, problem 14. Yep, so okay, they're doing a similar process to me. They're first taking a common factor of 13. Instead, I said, okay, well, let's do this part first. Because I don't know how we can just combine all three of the common factors into one. Like, I don't really see, that doesn't make sense to me, or how it's working underneath the hood. So instead, I took the common factor of these two expressions, this one right here, boom, 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 and I said, okay, well, let's apply the distributive property, and we factored it to this expression, but then we see that there's a 13 here, and I wrote down that, well, if we ignore this expression, we just assign it a variable of some kind. This is overkill. You don't really have to do this. But if you do, you and see that, well, this is really just this. Which means that we can combine these common factors and we get 13 a plus b. And then we can expand those variables to be 17 plus 51 plus 32. And we can see how we get the same result. So I guess assigning expressions to variables allows us to see things. That's very neat, and that's something I need to keep in mind when the problems do get harder and expressions get larger. So, well, we can now assign expressions to variables and then expand it later. So I'm gonna assigning expressions to variables allow you to see the bigger picture. So I'm just gonna write a little note to myself. Okay, last problem. Oh, they have like a key concept where we can have multiple. Okay, all they're saying is that, see how we have 3 common factors? Well, we can have n common factors. We can have infinite common factors. They can all be broken down or factored into the distributive property. And then we can do the same thing when the common factors on the other side. So it could be like b plus c plus blah 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 a, or it could be a b plus c blah 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 blah, something like that. We can do that. And they even give an example. You may have learned that multiplying by an integer is the same as repeated addition. Yep, I say that all the time. That's how I make sense of it. And they explain why. The distributive property combined with the rule that 1 times a equals a for any number a tells us why this is true. Oh, wow, that's crazy. Okay. So 4 times 7. Well, that's really just 1 plus 1 plus 1 plus 1 times 7. And that makes sense. I mean, they're equal. 4 times 7 does equal this, because when we go into the parentheses and add up all these ones, we get 4. So now let's distribute that 7. We don't need to do all that. And like, what in the world? 7 plus 7 plus 7 plus 7. They've officially explained why multiplication is just repeated addition. I never saw it like that before. That's actually wild. That is crazy. But they're actually, okay, so I should probably go into more detail here. They're doing this. And with the property that we learned before, 1 times a equals a, they've now just applied another property. Well, isn't that just 7? You see how it's all just like properties. Like each new property we learn, we're able to apply it to a new problem. That's actually pretty cool. Because this statement, this makes sense. Yeah, a times 1 for all a gives us back a. The 7 times 1, well, that's really just going to give us back 7. And then we could just repeat that. This 4 times 7, well, 4 can be expanded. Or not the 4 times 7, but the 4 can be expanded into repeated ones. Repeat the ones 4 times. So 4 times 1 times 7. Doesn't really make much sense. But this is another way. Like, these are equal. I got a little off tangent, but that's actually pretty exciting to know. Like, that's the reason why we say multiplication is repeated addition. Okay, let's move on to the last problem, and then we have to do the exercises. Okay, so what happens when we multiply a number by 0? Probably already know what happens, but let's try to see if it makes sense to the next problem. Yeah, so A we answered correctly. You just subtract 7. Like the list of numbers all decrease by 7. So each number is less than the number above it, and it's less than by 7. B, well, the prediction tells us that, or our prediction is that it will be 0 because we're just subtracting 7 each term. So that's 7, that's 7, that's 7. Well, 7 minus 7 will be 0. So we have a new definition. Anything, any number multiplied by 0 will always give 0. So we essentially destroy the value. Okay. Now we move on to the exercises. And there's 10 of them. Excuse me. So we have 1, 25 times 17 times 4 times 20. Okay. Well, it's going to be 80, but that can be 100 if we take these two. So that could be 100, and then 17 times 20. Okay, so I can do this. I can say 25 times 4, 17 times 20. Actually, I'll do this. Okay, there we go. Now this is 100, so that'll be 1700. And then we can now, so it's in this factored form, we can now expand that to be this, which we can then say, so we just add an extra 0. We can finally add them together, which gives us, gotta think about this, 17, so 30, 34, 32, oh Lord. Oh, 34, right? Yeah, 34. Okay. And then problem 2. What is 1 times 100 times 2 times 50 times 4 times 25 times 5 times 20. Okay, and let's make sure I wrote that down correctly. Well, I know that this is 100. I know. Oh, okay. So that's 100. That's 100. That's 100. That's 100. So we're all 100. So we have 100 times 4. No. We have 100 to the 4th power. So we gotta do this. That. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 3, 2 times 2. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 times 5 times 5 times 5 times 5 times 5. Well, we could just use commutative property and associative property to group them up. So it'll be 5 numbers total, or group, or 5 group terms. And that will all equal 10, which is 1, 2, 3, 4, 5, I believe. Okay, I think that's right. And then 4, that's an easy problem. They're just trying to hone in that anything multiplied by 1 will give you back 1. So it's 1,995. Okay. This one is similar. Not really. We have 25, then 5, that's 125. Right? Right. 25, yeah, that's right. And then we have 6, but it has 3 problems. So 11, 43 plus 11, 57. So right now, in its expanded form, we could take the common factor of 11. Now we have 43 plus 57, which equals, what is that? That is 100. So now, just do this. And then B, 22, 6 plus 6 times 38. It's a similar problem. It's in a expanded form. We have a common factor of 6, so we can then do this. 38. So now we're left with what 60, right? Yeah, that looks right. And then that is 20 or 30, 360. And then C, and then 32 times 16 plus 16, or yeah, and then 48. Again, expanded form, common factor 16. We can now do this. 32, 48, 16. That is, what is that? 4, 6, 7, 80? Right? Yeah. I have to figure out how to. I think I could do 10 plus 6, 80 factored form, expand it. So now we're left with 800 plus 48 or 480, and now we can then do 1280. I think that's our answer. Okay. Next problem. Problem 7. Find numbers A, B, and C such that A is not equal to... Oh, find an example that addition does not distribute over multiplication. So you have to find some terms where this is not true. So what can this be? What can that be? And what can this be? 0, 1, 2. Because that's 0. Wait. Yeah. This is 0. And this can be 1, 2. That's 2. That's 2. No, I think that statement is still true. What if we just did this? That's 2, 3. That is 2. That is 3. Yeah, so it's not true when the numbers are like this, because A is 1, so we do the multiplication. That's 2. 2 plus 1 is 3. Okay, this is 1. 1, that's 2. That's 1. That's 2. That's 3. 2 times 3 is 6. Oh, that's not the same as the 3. Yeah, so there's your example. So problem 8, we have, I'm not writing that all down. That is crazy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's easy. It's just this. Boom. There you go. What is the product of the numbers? Yeah, so they want this 9, 0, and the product of it. So that answer is just 0. Bam. We're moving through this fast. 10 plus 110 times 0 times 101 plus 11, or 111. Okay, let's focus on this part first. Oh Lord. We know that answer is just 0, so there's no point of writing this. Like that, and then this answer would just be 1, 2, 1. Okay, now let's check our answers. Make sure we're right. Okay. This one's right. This one's right. Just gotta put those commas. Yep, that's definitely right. 3. That's right. 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 They use different numbers, but I still get the same thing. Four, 5, 6. That's right. That's right. And that's right. We got all the problems or all the exercises right. So, good job for me. Yay. It's pretty good. And that will conclude this stream. Yeah. I had a lot of fun. Actually, I almost missed this stream. I was too busy doing some stuff since it's the holidays and Christmas is coming up. So I was busy. But yeah, I had a great time studying some math. I learned a lot, refreshed on the basics, which was pretty good. Now, I actually want to know how I can upload this video or this stream onto YouTube as a video. So how can I phrase this? How to upload on YouTube. So I'm assuming that I can just end the stream.